Problem 2 describes Dave leaving his office in Paddleford Hall, which I'm gonna refer to as P, on his way to teach in Gold Hall, which I'm gonna refer to as G. The problem gives us different scenarios, and for each scenario they want us to graph the function s equals d of t, which keeps track of Dave's distance from distance s from Paddleford Hall, or Dave's distance s from Paddleford Hall at time t. Distance is in feet and the time is in minutes, and the path is going to be a straight line that length's 2,400 feet. So scenario A asks us to sketch a graph from Paddleford Hall to Gold, walking at a constant speed and reaching Gold in 10 minutes. So here's my graph. I have time in minutes at the bottom, and then I have distance in feet times 100 just to make things easy on the y-axis. So you at time 0, you have Dave starting at distance 0. This is going to be distance from P. And then he's going at a constant speed. This isn't changing. And then at time 10 minutes, he's going to get at Gold Hall, or 2,500 feet later. Scenario B describes Dave traveling from P to G at a constant speed, halfway P to G at a constant speed in 6 minutes, and then he pauses for 1 minute because he's confused, and then he finishes his trip at 2 times the speed. Oh, that's right. So I accidentally did C in place of B here, so we'll just do C first, and then we'll come back to B later. But so we still have him at starting at 0, 0. He's traveling halfway the distance from P to G, which is 1,200, in 6 minutes. That's going to be a rate of 200 feet per minute. You can see my work down here. And then he stops for 1 minute where he's confused, and then he travels at twice the speed, or at 400 feet per minute. So he's going to get there in half the time it took him to get from 0 to 1,200, which is just 3 seconds. So he arrives at Gold Hall in 10 minutes. So back to part, this is supposed to be B. So similar problem, it asks Dave's travel. He goes halfway between P and G at a constant speed, then pauses for 1 minute, just like last time, but then he continues at a constant speed. So he starts at time 0, goes same thing, halfway, 1,200 in 6 minutes, stops for 1 minute, and then travels at the same speed, which is 200 feet per minute, which means he's going to get there, and the same time took him to get halfway, just a minute delayed, at 13 minutes. Part D says that Dave's going to go halfway between P and G at a constant speed again, stops for 1 minute, but then this time he's going to go back to his office at the same speed. So here's him at time 0. At time 6, he's traveled 1,200 and is at a constant speed. This little flat part is where he's confused, and then he goes back to distance 0 where he started in time 13. Moving on to part E, it says Dave travels from P to G at a constant speed. Angela is traveling from G to P. Angela's speed is going to be twice that of Dave's. So you have Dave's line starting at 0, 0, just like it has been, and he gets to, it doesn't tell us what speed he's traveling at, so I just used the same speed from A, where he travels 2,400 feet in 10 minutes. It also just kind of makes your work easier. And then Angela's speed, since she's going half the speed, but starting from Gold, she starts at distance 2,400 and ends up at distance 0 at P, and half the time it takes Dave. So that's what that looks like. Part F asks, suppose you want to sketch the graph of a new function s equals g of t that keeps track of Dave's distance as from Gold Hall at time t. How would your graphs change in A to E? So I just said that if I wanted to sketch a new graph from A to E, but this time traveling from G to P instead of P to G, they would be similar except the slopes that he's traveling at, they're going to be perpendicular to the slope in their respective graph. So if I had a new A, it would be perpendicular to slope from the one from slope, or the original problem A, which is just going to be inverting the slope and then making it negative. And then at time 0, his distance is going to be 2400, and then at whatever time he finishes at, his distance is going to be 0.